It would be very helpful if you first try to solve the problem yourself before watching this video.
Question 74. If the function f is defined as above, which of the following is true? So let's look at the answer choices. Answer choice A, we have f is continuous at x equals 3. The function f is continuous if the function value is equal to limit value, right, at x equals 3. So when x is equal to 3, the function value is negative 9 over 8. So f of 3 is equal to negative 9 over 8. And we want to check if the limit value, the limit as x approaches 3, f of x, this expression right here, is equal to the function value f of 3. Okay, so we have 2x squared minus 3x minus 9 over x squared plus 2x minus 15, right? So let's simplify this. Factor numerator and denominator. If we factor numerator, that's going to be 2x, x, we have negative 9, so minus 3 here, plus 3 here, right? So 2x times minus 3, that's minus 6x, 3 times x plus 3x. So sum of those two terms is equal to negative 3x. And 3 times negative 3, negative 9, right? Here, denominator. Denominator is easy. X squared plus 2x minus 15, that's x plus 5, x minus 3, right? So cancel x minus 3 from numerator and denominator. And the limit value is equal to then substitute 3 for x, right? So that's going to be 6 plus 3, that's 9. 3 plus 5, that's 8. Well, the limit value is actually positive 9 over 8, right? Which is not equal to the function value, f of 3. So this is not true. The answer choice A is not true. F is not continuous at x equals 3. So far so good? Okay. Answer choice B. Limit as x approaches infinity, f of x is equal to 1 over 2. And let's see if this is true. Infinite limit has to do with the horizontal asymptote of the function, right? So this is a rational function, right? The degree of the denominator is 2. The degree of the numerator is also 2, right? I mean, highest degree. And if the degrees are same, then horizontal asymptote is always equal to leading coefficient of numerator over leading coefficient of denominator, which is equal to 2 over 1, right? Not 1 over 2. So B is not true. Does that make sense? Okay, part C, answer choice C. Limit as x approaches negative 5 from left-hand side, f of x is equal to infinity. Okay, let's see if this is true. F function is right here, and we simplified it. That is equal to 2x plus 3 over x plus 5, right? So let me rewrite that. F of x is equal to 2x plus 3 over x plus 5. And denominator is equal to 0 when x is equal to negative 5. So we have vertical asymptote at x equal to negative 5, right? Vertical asymptote occurs when the denominator is equal to 0. So let's draw the graph. Here's y-axis, x-axis. Here we have negative 5, right? Negative 5. So as x approaches negative 5 from left-hand side. So as x approaches negative 5 from, that's from right-hand side, I'm sorry. Okay, from left-hand side, from here to here. Okay, what about the function f of x? Here, I'm going to substitute, let's say, value negative 5.1. Okay, so substitute negative 5.1. Negative 5.1. Okay, we don't have to find exact value of f of x when x is equal to negative 5.1. All we have to know is if this is positive or negative. Okay, so if x is negative 5.1, is this positive or negative? Numerator first. Numerator is negative, right? 2 times negative 5, that's about negative 10. Negative 10 plus 7, that's negative. So this is negative here. What about denominator? Negative 5.1 plus 5, that's negative, right? So negative over negative is equal to positive, right? So as x approaches negative 5 from left-hand side, the function approaches to positive infinity, like that, right? So C is true. C is the answer. Okay. The answer choice D. F has a vertical asymptote at x equals 3. Well, we canceled it out, right? The factor x minus 3 is canceled out. If the factor is canceled out, we will have whole, right? Whole at x equals 3, not vertical asymptote, right?